Welcome, everyone, and so happy to be here and happy to present a quantitative data analysis workshop. Hopefully, you have data or you're going to be getting data, and and I know one individual has sent data over, and I'm happy to interact with them if I can, and I think we can unmute them. So. Let me just first start by asking, well, so one individual has shared analysis. Can, for the individuals that are here, we have a good bunch. I have a whole, well, let's just talk about the agenda and what we can do here. So the agenda is understanding the basics, what the names of variables are and what levels of measurement are, creating an account, setting up your data, conducting the analysis, and download and final Q&A. I don't want to bore people with the basics if you don't need it. So I guess my quick question is, how comfortable is everyone with what an IV and a DV is and levels of measurement? If even one or two individuals need to have a little refresher, no problem, we'll get to it. So if you can put that into the Q&A, that would be great, just so I know what's happening here. And just give everyone a minute there. I guess I'm also curious if you actually have data or you're just in the preparation stages. So what's your comfort level with independent, dependent variables, with the levels of measurement, nominal, ordinal, scale, and with the and where you are in the process. So I'll just give everyone a second there. I don't need the basics. Brief review, refresher, please. Okay. All right. So, okay. Okay. All right. So, because there are few individuals that would like a quick basics, I will go through that. I'll do that quickly so I don't bore anybody. So this is important because levels of measurement and what the name of these variables are is important because the tool really will only allow different types of levels of measurement for different types of analysis. So we need to just know that there's three levels that we're talking about: nominal, ordinal, and scale. Nominal is Latin for name only, which is male, female, Republican, Democrat, Independent, and so forth. Just labels, no orders. Okay, ordinal does have orders. So it's names and orders. So a 8-ounce Coca-Cola, 12-ounce Coca-Cola, big gulp, 35 ounces, or however big these things are, there's an order to it. Horse race, first, second, third. The key thing about ordinal is that the interval in between the first, second, third, okay, do not have to be equal. So first place horse can come in, okay? Second place could be a nose behind. Third place could be, 10 lengths behind. So while they're ordered, they don't have equal intervals in between them. Scale, as the ruler implies, and people call it interval ratio, and there's some distinctions there, but for the purposes of this presentation, just know that scale has names like nominal, has an order like ordinal, but it also has equal intervals in between. And that's kind of the simplest way of presenting those three levels, okay? And I think some of these presentations, fruit, banana, okay, apple, orange, they're just names of fruits. Ordinal, sedentary, moderately active, very active. Again, there's an order to level of activity, but they're not necessarily equal between sedentary and moderately active, and between moderately active and very active. Scale, temperatures is one, age is one. Again, equal intervals, whether you're going from a 5-year-old to a 6-year-old, you have 365 or 366 days. If you go between 45 and 46, you have 365 or 366 days. So everything is equal in between these levels. Okay, and then I'm not going to get into this. I do need to go here. Sorry. So so that's levels of measurement. Nominal, ordinal, scale. I will not quiz you, although I want to. I will not quiz you on those, but just know that there's 3 levels that become more granular as you move from nominal to ordinal or ordered, and from ordinal to scale, which is equal intervals. Okay. Let's talk about how we name variables, right? So typically independent variables are things that the researcher controls. I want to look at GPA by gender. So gender is my independent variable, and I'm saying, I want to look at males versus females, or these people are in a control group, these people are in an experimental group. So these are typically things that the experimenter really dictates. Okay. Conversely, a dependent variable is really dependent upon the respondents or participants, right? So what is GPA? Is there differences on GPA by gender? Well, the researcher is saying, I want to compare these 2 groups, that they're controlling that, but the GPA is dependent upon those participants, okay? Or, different races, 1 mile race times by, age, okay? Researcher is saying, I care about different ages and how fast people are running the 1 minute mile, or the 1 mile or a marathon. The dependent variable is the actual time that it takes those males and females to run that mile or a marathon. Covariates are typically things that we want to control. That is, if I was looking at for example, if I was looking at I'm interested in how fast people run, a marathon, and if it differs by males and females, that's my main research question. But then the researcher says, look, I found out that men happen to be older running these things. Women tend to be younger. So maybe it's the women are faster because they're younger, but that's not the real question at hand. The question at hand is, are there differences on run times by gender? So we may want to neutralize the effect of age or control, that is, use it as a covariate, use age as a covariate, so we can get to the heart of our research interest, which is, are there differences on run times by gender? I should say, both with levels of measurement as well as with independent, dependent, and covariate, you don't have to get it the first time out. So it's okay. This is being recorded. If everyone wants a getting started guide, we're happy to provide that, and maybe we'll send you that PowerPoint that really goes into a lot of detail around these things. All right. So let's log in. So as Melissa's put in the webinar chat, ask questions, but also if you're having trouble logging in, we want you to get logged in. So everyone should do that. While folks are getting logged in, let me just state that after, well, going on 25, maybe 30 years now, I think 30. So that there's common issues around quantitative data analysis. And in part, it's inspired by just not having that orientation and getting that. And I hope this presentation helps to get people oriented. So 3 common problems are, they don't know which test to conduct. As it turns out, the test to conduct is based on 2 things, typically. The phraseology of the question, I want to see if there are differences on run times by gender. Ah, differences. Okay, we're kind of in t-test land or ANOVA land. Does the amount of calories consumed, predict run times, something of this sort. Ah, predict. That sounds like we're in regression land. So selecting the test is based on the phraseology of the research question or the study aim and the level of measurement, okay, which we just discussed, nominal, ordinal, scale. So those two pieces of information really drive which test. And I will briefly show you how we can use the decision tree inside of Intellectus to use those two bits of information to figure out what test to conduct. The second problem that most people have is how to conduct it. Not only how to conduct the test, but how to assess the assumptions of the test. And then, okay, so how do I navigate this tool? So we really tried to flatten that learning curve, as flat as possible by making it intuitive, putting things kind of in some logical fashion, which I'll show you in a minute. Okay, so tying the assumptions to the particular tests, right? So some tests have these assumptions, other tests have those assumptions. Well, we just marry those together. And so to facilitate the conducting of that analysis. The third part that people trip over, and if you've tripped, then you're in good company, that, what does this raw output mean? How do I interpret some of this or all of this? How do I interpret the assumptions output? How do I interpret the the F values or the probability levels or the effect sizes? Okay. And we've done our best to have interpretation in plain English, that is written out sentences. There was a statistically significant difference on run times by gender, where females had ran faster than males in the marathon. So we'll get to all of those. So if you struggle with any of those pieces, you don't know what to conduct, you can't navigate the tool, and what the output means, Intellectus is here to support around those three common things. Okay. And loading your data. So let's just get to it. So if you have your own data, you can do this. If not, I'll show you how to upload your own data. So let me just get to so to upload data, you log in, and I presume that Melissa and Ashley are helping you get logged in. So let me just talk about this platform for a second. Projects is where we're going to upload data. Management is where we're going to manage data. Plots is where we're going to visualize data. Analysis is where we're going to analyze data. So we're going to be messing with these four buttons up here to upload, manage, plot, and analyze. I should also mention that these three buttons are really kind of a priori buttons. And what I mean by that? What I mean by that is that before you collect data, which some folks, this was the basket you're in, the decision tree to help us figure out what test, the assumptions of the test, and the sample size for that test. So that's a priori. And I think I'm going to just start there. So let's just take the example that I've been kind of using. I have a research aim or a study aim, and I want to see, are there differences on marathon times by gender? So I can go to the decision tree, okay? And you can play with all of these. Most people, to figure out which test to use, are really kind of walking along these branches. Well, I'm looking at differences or relationships, and do I have one dependent variable or covariates? So, but let's just take this example. So Here, I want to explore differences by groups. Yep, I want to explore differences on marathon times by group, which is males versus females. Click on that. Do I have more than one dependent variable? More than one outcome variable? Nope, I only have one. That is, what is their race time for a marathon? So I have one dependent variable. So do I have more than one? No. Do I have any covariates? Well, I didn't ask about age in my question. I didn't ask about anything else. So I'm not trying to control for or neutralize the effect of any other variables. Okay. And do I have more than one independent variable? That is, am I looking at it by, gender and region or some other variable? No, I only have one independent variable. That is what the research controls, which is I only care about males versus females. So do I have more than one independent variable? No. Does my independent variable have more than two levels? No, it's just males and females. Now, given this time in our society, you could have more than two levels and you could have, non-binary or whatever. But in my example, do we have more than two levels? No. Okay. So two tests come up here, right? And this kind of describes that second test. But basically, we're conducting an independent sample t-test, okay? So we're looking to see that t-test evaluates whether there are differences on runtime, okay, by gender, okay? All right. And you can play around with just drilling through these things and using some of that knowledge we talked about earlier, which is levels of measurement and names of variables. Okay. Following along that path for a moment, once I know I'm doing an independent sample t-test, which is just one of numerous tests, but the correct test for this research question and these levels of measurement, which I should have said, which was the run times is a scale variable, right? Could be in, hours, minutes, and seconds, and nominal binary, okay, dichotomous male versus female in my example. Once I know I am conducting an independent sample t-test, then I want to know what are the assumptions of that test. So you can click on to the different tests. Okay? And here you can see there's a research question template, but importantly, there's a data plan. So the data plan is going to talk about, what the research aim is, but also the assumptions of that. This is going to be helpful for those folks that have not done the data collection for your methodology, and it's got to be sent to IRB. So you can download and edit this document, and it has references as well. So what is the test? What is the assumptions of the test? Power analysis. Here we're figuring out what the sample size is. So we click on the test again, and without knowing anything else, you can select the medium effect size just to give you a ballpark of that you're going to need approximately 128 observations, that is 128 males and females, to do this test, to conduct this test with a likelihood of finding differences if they're there to be found. If you had too small, right? If you had 3 people and males or females were faster, it's tough to say, oh, I have a lot of trust in that, okay? All right, so just to know that the power analysis helps determine a sample size. And we can talk, there's another conversation about which effect size to use, but you have some sense of the sample needed. So this is those 3 buttons are the a priori. Again, what analysis, what are the assumptions of the analysis, and what's the sample size? Okay. So let's get to it. So now let's just deal with the top 4 buttons, which is uploading data into projects. You can see upload data, enter data, management, I probably have to select a test. I can select this test for the moment, and whoever sent that project in, I'm happy to work with you there as well. Management is managing that data, modifying the data, creating composite scores or subscales, plotting data, different types of plots, and then the analysis of the data. Get rid of this. The analysis, which really is pretty comprehensive. I think it's over 60 tests and lots of permutations therein. So let's, for those following along with your own data, first of all, great for showing up with data if you have data. I just go to upload data file, okay? And then I can click on the file format, in this case, Excel, choose a file, and I'm going to go to Rosenberg self-esteem scale. Now, what we've added in this, so that's one way to upload data. Okay. Once we have data, and I think this is probably worth doing. So the data cleaning wizard, for those that do analyses often, for those that don't do analyses often, you will find that data cleaning takes most of the time. I mean, it's a brutal fact that imagine having to clean your house more often than you actually live in your house. It's just the nature of the beast that data cleaning takes 70, 90% of your time. The analysis, 5 minutes. So this data cleaning wizard was designed to help do things like if you upload from Qualtrics or SurveyMonkey, you can remove those additional headers. You can update variable names, correct misspellings, all problems that occur. Often people have Likert type items. Let's get those labels, strongly disagree to strongly agree, into numbers so I can actually create a subscale. Creating a subscale and add an ID. And let me just quickly go through this. As I say, this is all being recorded. Don't try to take notes, I would suggest, and just kind of get the feel for what's happening. And then if you want to go back and then, look at the video, terrific. So let's go to next. So here we can see we have several layers of headings. Question 1, question 2, what's your age, what's your sex, and then the different options here. I might want to dump those, okay? All right. And apply changes, that is delete those rows, those headers. Then go to the next. I might want to edit my variable names. So I can put, sex in here. I could, this could be group, right? And so forth. Okay. All right. Apply changes, next. Okay. Here's misspelling. So even in platforms like SurveyMonkey and Qualtrics, strangely enough, you can sometimes wind up with different spellings of male with a capital M or male with a small m. Here, I happen to have disagree, one with 3 E's and 2 E's, but disagree means disagree. So I want to merge those, okay? This is my levels before on question 4. Here are my levels before. After I merge, you can see the disagree with 3 E's goes bye-bye. So it gets collapsed into disagree. So that may be one merge I want to do. And there's other merges that I could do. Let's go to next. Do I have Likert scale? Yep. You haven't seen this, but so here I have Likert type scales in my data. So it happens to be a 5-point agreement scale. That looks like that. If you have other scales, it's not going to show up. So if you pick 5-point satisfaction, so, okay. You have to know what your levels of measurement are. Mine happen to be agreement. Strongly disagree to strongly agree. That really needs to be converted to 1 to 5. And all of these items, okay, all of these items have that Likert type scale. So I'm going to apply changes. So basically what I'm doing is I'm changing these labels, okay, into numbers. Okay. Apply changes, go to next. You can also create subscale. So if you have any kind of a subscale, be it leadership, be it whatever, okay, knowledge, okay, confidence, whatever. Those items have to be, or those questions have to be aggregated. So I'm going to add a subscale. Here, I really just want my items here, okay, all right. If any of those are reverse scored, what that means is that so if I was surveying people's satisfaction, okay, employee satisfaction, I could be asking lots of questions. How satisfied are you with, your daily routine? How satisfied are you with your fellow employees? How satisfied are you with your compensation and so forth? But I can also ask a question like, how dissatisfied are you with your vacation time? Okay. For example, I'm asking a question in reverse. And if I want to put all of those items together, I need to flip those. And I do that and by the way, in scales that are being used, they will tell you, okay, that item was asked in a reverse manner. You're asking the negative of that item. And you can put the reverse coding scoring in there. You have to name it, okay? And you have to identify how you want these things to be done. For example, averaging or summing those items, apply changes, and then you can see that a subscale has been added. Next, we suggest putting a ID variable in, just in case you messed up here some way. You put in a 55, you can go to participant number 5. So you should label your surveys, your responses rather, and finish. So basically what we did is we cleaned up the headers, okay? We renamed some of the variables. Oh, I guess I didn't do those. Okay. And then we came up with a total score. So these should have been changed as well. I didn't get those. And then add those into that total. So that's one way to use the data cleaning tool. So uploading data and then using that tool. You can also enter data manually by just pasting it in there or typing it in there, okay? All right, that's another way to get it in there. You paste it in an Excel file or a flat file. You can, and for those that want to follow along, you can use an example data set. And I think I have let me just choose this. Okay, so you can go to click on the name. So these things are in alphabetical order. You can then go to masterclass and go to select, create a project with this data set. Yep. And there's your data. So I want to give everyone a second to do that. And I will seek to support the 2 individuals that sent the data along. So let's make sure that everybody can do that. Yep, Thomas, so we will get to that. Thomas is in the analysis part. We'll get there. So yes, you have ordinal and multinomial regression. Okay, so once we're here, we can do other data management things that were not in the in the data management wizard. Okay. Okay. So create composite scores here. One interesting thing that we have here, let me see if I can find it. Perfect. So one thing here, oftentimes folks have basically a quantitative survey, but then they ask, okay, they ask qualitative responses, like open-ended responses, like, what did you like about the leadership at your school or organization? What we've added is a text classification. So basically what that text classification does is that it's going to take, it's not a full-on qualitative analysis or thematic analysis, but it will take those responses and either automatically bucket those or manually I can select the number of categories. Okay. All right. So, and it will automatically bucket those responses. All right. Well, I've actually bucketed them here. All right. And if I go to look at that variable here, and if I go to descriptives, just jumping ahead a little bit, sorry. Leadership nominal, that's the buckets. So it turned those 30 responses and it then labeled them with these 3 segments: leadership qualities, principles of leadership, and the philosophy of leadership and empowerment. The beauty part of that is that now once I have those buckets, I can sort these. Once I have those buckets, I can now use those buckets to interact with my other data. Okay. So that's something that is trying to mix some aspect of mixed methods in there. Okay. Let's jump to some data sets here. So this is SBODN. Okay, so we can load project. So what's happened here is I have a, my ID variable here, gender. You'll notice he or she just uploaded. Melissa, can we unmute him or her?
We can. If you could raise your hand
Perfect.
and then I'll know it's you.
Okay. So what's happened here is that there was 2 rows of headers, okay? And we didn't get that we didn't get that in there. So what we can do is these are the, again, ID variable, gender variable, physics anxiety, and then there's other items there, okay, with a total score. So we can ask the question, are there differences on that total score by gender? Okay. So let's just do a little cleaning up here. So I'm going to go to edit data. And let me get to here. So here, I'm just going to label this gender. Okay. All right. Here, this just looks like an ID variable. Okay. Physics anxiety, hunky-dory. And then, these are items, really 2, 2 through, whoopsie, 2 through 10. Okay, and then a total score. So I'm going to put the score here. All right, and then let me just, so I keep my own head straight here. Let's just call this Q2. Okay, Q3, Q4, Q5, Q6, Q8, Q9, 10. Okay. So, and then I also want to get rid of this variable here. All right, so I'm going to remove that. I would say mute yourself if you're, okay, so let me just remove that row. Okay, so I have a few things going on here. So I have a physics anxiety, I have a total score. Is that individual online?
They are. Yep.
Yeah, hi there.
Yes, I'm here.
Hi, how are you?
Hello.
How are you?
I'm very fine. Thank you. How are you, Jim?
Good, good. Where are you, in New Zealand?
I'm in South Africa.
South Africa. Well, welcome from South
Yes.
Africa.
Thank you very much.
Sure. So we've cleaned up pretty good. So you have a physics anxiety. That's really a scale variable. Is that right or no? What type of
Um,
variable is that? I see 1 to 5. Is that
okay. What I did was I just wanted to determine the anxiety levels based on the questions that I have. So I have about 10 questions,
yeah,
and the student answered based on either disagree, agree,
got
and
it.
all of that.
And that's how we
So
got this total score.
exactly.
And that score reflects anxiety?
The net score determines whether the student has a higher level of anxiety or medium level or lower level. So I had this total score, the marks vary
Right.
with a maximum being
That's
a
fine.
highest level of anxiety.
Got it. Okay, so so I'm just going to change it to a scale. So how does this score, okay, differ from this score? This is physics anxiety, or was this just one of the this was one of the items in this thing. I see. Got it. I understand. Got it.
Yes, exactly.
Okay, got it. This is really
Okay.
this is Q1. Okay. All right. So, okay. The other thing I would do is to, so you want pretty tables. So I would just go here to manage and just change these. So I went to manage and went to female. Okay. And then go to male. Okay. So okay, great. So let's just run some descriptives and let's just assume we have a question of what is the overall anxiety level in physics, A, and B, are there differences on anxiety by gender? Fair enough?
Exactly.
Okay. So let's just go to analysis. So first we want to run descriptives. As I say every time, you absolutely want to run descriptives on your variables first. So I'm going to gender and score is the relevant variables. Let's just talk about the conducting of it too, by the way. All we're doing is selecting the test, putting the variables of interest in, and hitting confirm and calculate. That's all we're doing. Okay. Here we can see males and females. Okay. The frequency and percent. So you got almost a 50-50 split. And overall, the scores range from 24 to 37. And the mean is kind of in the middle there at 30. Okay, great. So running descriptors is important. If you had 339 males, you'd say, yeah, something's wrong. If I had a max of 337, that would be a problem, right? That's a data entry error. So you want to run descriptors first. All right. As in my example of running the marathon times by gender, it's that independent sample t-test we talked about. Here, now that we know the dependent variable, that is the anxiety that the participants identified, and our independent variable, which is gender, in this case, all we do is select the test, put in our dependent and independent variables, the ones that the researcher selected, and the ones that is dependent upon the participants, right? Because the researcher doesn't know their physics anxiety scores. The students are, or who's ever taken it, that's theirs. That's their scores dependent upon their ratings. Okay. So then we hit calculate. So with t-tests and other tests, there are assumptions. When what happens here is the assumptions are identified. Here it's normality and homogeneity of variance. There are different tests, Shapiro-Wilk test for normality. That test was conducted, and the result is interpreted. So that assumption is met. So when these things are non-significant, that is the p-value is greater than 0.05, we say, that assumption is met. And basically, by the way, just for basically what that's saying is this. Basically, the normality assumption is saying, does that look like a bell curve for males and for females? Okay. And if it's similar enough to a bell curve, which that looks like it kind of it is, then that assumption is met. Normality assumption. The other assumption is homogeneity of variance. Homogeneous is similar. Variance and standard deviations are similar. What that means is that are those standard deviations for the females similar or homogeneous or close to it as the males' standard deviation? If in fact they are similar, then that assumption is met. Levine test is the test to assess that assumption. The tool runs it and interprets it. Simple. So yippee skippy, both assumptions are met. Okay. Then we have the results of the test. They were not statistically different from each other. Okay. This is one way of reporting it. Okay. If there was a null hypothesis, that is that there were no differences between them, then you cannot reject that. Basically, we're accepting the null hypothesis, not to get too complicated in hypothesis language land. But okay, so basically we're saying that males and females scores did not differ from each other with respect to physics anxiety. And you can see these scores are almost exactly the same, all right? And almost exactly the same spot. So you can see the bar plot there, and then you can just download that document into an editable Word document. And by the way, since you shared that with me, you'll be able to get that back. You'll have everything, my pleasure. You'll be able to have all of these results are already associated with your project. So, but let's look at those results real quick. So this is what we did, descriptives and the t-tests. Here's our APA table, by the way, with a little description about what's in that table. They use APA over in South Africa. Ma'am, did they use APA formatting in South Africa?
Actually, we use SPSS.
SPSS is the program. What
Yeah.
what
I
format?
captured with the Excel spreadsheet, and then I initially did the analysis, but the output generated were not coming out right the way I expected it to be. That is it.
Well, listen, if you knew that they were going to come out exactly as you suspected, why do the test? I know females are going to have higher physics anxiety scores than males. We don't know that.
Yeah.
You have to be able to accept those responses. This is one snapshot, but it's not the whole thing. What I was asking was, when you do you have a printing format? Do you use
no.
MLA? No. Okay, no problem. All right. So so we have this with a description. So here are the assumptions. Here are the results, that there are no differences in the plot, and then the references. We also have a glossary of terms and symbols as well for the tests that were conducted. But okay, one caveat. So we did not want students and faculty to take the results and plug it into their results chapter, okay? So we've purposefully published this with Turnitin, okay? So anything that looks like it's a templatized part, you have to put in your own voice. I recommend just putting it into ChatGPT, say edit, simplify, and make sure that you understand it. So just to reiterate that tables can be used straight up. Those are your numbers, no problem. Plots can be used straight up. That's your data in that plot, no problem. The accurate interpretation, no differences, okay, can be used, no problem. However, other things need to be put in your own voice, okay? So that's the caveat. So just a heads up on that. Okay. All right. Nice job. I hope this helped. Let's go look at the next project. So the next one we have is Halam from Kent. How you doing, Halam? Well,
If you could just raise your hand, we can unmute you. Oh, here, I think I found you.
okay. So a little bit more complicated of a data set, although not much. Okay, so there's a few things going on here. So this is a great, and I'm going to try it. I'm not sure how it's going to do, but we're going to find out. So you have a lot of data here, which is great. And you have some scores here. So I would say, let's just do one thing first. So while we're here, let's just see that my text classification can work. I'm pushing my limits here because I had ad bombed on the first time, but agitation, concentration, tiredness. Okay, so I can go to text classification. Okay, so that's nominal. So text classification, behavior score. I want a nominal variable. So I need to look into that. So,
well, those are default. I mean, those are forced choice responses. So those weren't open.
I say those are not open-ended per se. Yeah, but still my tool should be able to look at those. But so those are good for descriptors. What's your Jeff? Okay. Got it. So all right, so great. So you've loaded up your data. Good job. It looks like you did do a good job of that. Okay. And then you have some variables over here, which seem like they're probably of interest. What kind of research questions did you have here, Jeff?
Well, the primary research question is exploratory factor analysis of the KABB items.
Okay.
So what I want to be able to do is I need to cut this or randomly select 500 some participants and do an exploratory factor analysis on 500 people and then do a confirmatory factor analysis on the other 500 is where I was trying to go with this.
Got it. So, okay. So I'm happy to do some of that. What I would do is two things. So I'm going to do some other things because we have a lot of people on the line. I want to be
Sure.
Okay. But one thing I would do is I would go to the edit data. There's probably a faster way of doing this. Let me see here. I think what I can do is new and really, and then I'm going to create a variable and then I'm going to have, let's just say, trial. Okay. And then I'm going to have, first 500. So I call it trial A. And I think I could just drag this down. Okay, great. So I can drag that down to 500. Okay. Is the 500 on the dot?
It's a little, I think I've got 105 in there, so. Or 1,005, sorry.
No, okay, so 502.
Yeah.
Great. And then we'll have B. Trial B. So, folks, this is talking about, and let's go 1,005. So this is the kind of data management that, is necessary. So he's got a reasonable question, but we have to add data. Oopsie. Okay. All right. And then I think you just grab this whole column here, copy. So I think what I can do here is just add a column. Add a column. There we go. Added 2 columns. Okay. So then paste this. Paste. Nope. Let me just do this. Control V. Okay. So here I have Charles. So what you want to do is when we and I'm gonna go to save. So let's just do a few things here. So let's just run descriptives, which we always want to do. Okay, so here's some things already. Let's just do some descriptives on other things. Let's just deal with that first 500. Okay, so just for okay, let's just look at age and gender and race and maybe whatever, some other variable. Okay, all right. But the important part is that I only want to start dealing with my first sample of A. Okay, so I want to filter on trial. Okay, and just use A. Right, I'm going to do my EFA just with A, and anything else just with A. Then when I go to do my confirmatory part, I'm going to deal with just with B. Got it?
Got it.
Okay. So I can run descriptives, any other analysis, just with trial A. Okay. And where are you out of, Jeff?
I'm in Kent, Ohio.
Kent, Ohio. Okay. All right. Cincinnati, other side. Okay, so back 20 years ago, schooling. All right, so now I can say, hey, you know what? Here's my descriptors for those first 500 I'm dealing with. Okay. And that's shown up here. All right. Then you can do things. So just so everyone else knows, we can do descriptives and correlations and blah blah blah. There's lots of things to do, but at the moment, we're dealing with an exploratory factor analysis with the K8 these guys.
Correct.
All right. Okay, so we're going to select these guys. I should go in order. Let me do this. Let me unselect these. So as it turns out in our tool, the order that you select them, that's how they show up. So I should be,
Good
so
to
it's,
know.
it's a little nuance. Yeah, because they're going to want to see these things in order. Okay, and how are we doing on time? All right, we're getting there. So, all right, I may not be able to get to the CFA, but okay. Because I want to save the questions. Okay, so, all right. So here's our items. Factor selection, I think we're just going to use Kaiser. And that's it. Almost slipped. And filter just by our trial variable. Okay. All right. And then run it. So it's just going to deal. So what that filter is it just looks at the groups that we're looking at. And you can see in pretty short order, that's not the prettiest thing in the world. So you get 2 factors. All right. So that came out of this thing. 2 factors accounted for 40% of all the variability in those KABB items. 40% of them can be accounted for in these 2. That's kind of pretty. That's almost as pretty as it gets.
That's a pretty good instrument.
That's a pretty damn good instrument. So did you make
Good
it?
to know. I
Did you
didn't know
make
that before, so that's great.
That's as sweet as it gets. So what's happening here is that K1 through 7 and 16 are all loading together. That is, they're highly related with this factor 1, whatever that's called. So some name that captures those. By the way, if they don't already have a name, ChatGPT would do a great job of taking all of those 1 through 7 and 16 and say, what is a good name for these?
Huh.
And then you have KABB 8 through 16 all go together. Hey, what's going on here? No 17. Okay, so in our tool, if you have a loading, that is, some item is not related to that factor above 0.32, it just suppresses it or deletes it or hides it. So just to know that that's pretty darn good. So that's what you got, okay? So that's a good start. And you got a great sample too, by the way. So you got a great sample, you got a great instrument, but I rarely see that in practice. This is real data, I presume.
It is.
That's amazing. Hooray for you. Okay, so the other thing you're going to want to work with is really the path modeling and the CFA. Okay. All right. And there's videos. There's a video on that. Okay.
Yep.
So just heads up there. Also, if you get stuck, although my sense is you're not going to get stuck, there's also consulting sessions. Should put a plug in for that. $150 for 45 minutes. They're going to get you through that.
Okay.
So, but I would try, look at the video. Melissa, if we can get him the PowerPoint on SEM, that'd be great.
Okay.
And then if you run into trouble for you or other folks, know that there's help around methodology, help around for an analysis, 45-minute shots, or there's a much more expensive option over here. But if you need to get it done today, it doesn't matter how long it takes us, we're going to work through that with you. Okay. All right. Let me just open up for questions. Jeff, thanks for sharing that. By the way, that's when you open back up again, you take that project back. You'll have all those results that we just talked about.
Okay. Great. Thanks.
Yep, my pleasure. Okay. So other folks, question or answers. So okay. So please do ask away. If you don't have questions, know that you can always ask questions. Melissa, you want me to put in my email? You want to put in yours or Ashley's questions?
Yeah, I'll put it in here.
Okay. So you can always reach out to us after to, ask questions about the tool. If you want to subscribe to the tool, I think it's like $59 a month somewhere, or maybe it's $70 a month somewhere, kind of inexpensive to get that kind of output in English that you can download. Also know that you can access courses. Jeff is on the house, but you can access courses. We can get to it. So, you can look at, an ANOVA or something and like $5. So it's a course that both quant and qual, but you can drill down just by quantitative. And so just know that there's lessons, just talking about the assumptions and what it means, and make sure you have the right question aligned with the right test and so forth. All right. Other questions? Okay, so Hatal, raise your hand. Do we have a question there?
Yep, let me unmute. Hang on just a second.
Hi, Hatal.
Hi, can you hear me?
I can now.
Oh, hi. I'm a professor here at the university, and I teach a doctoral program where my students are doing research and analyzing data.
Yep.
And this will be a great program for them to help them analyze and understand their data.
Yep.
Do you have any review programs or anything like that my students can join so they have more information?
So we can do lots of things. So we can get a trial to you. We're happy
Uh-huh.
to do, a demo for you. We're happy to get, there are 60 lessons, give or take, that I'm happy to share with you to review
Mhm.
if you'd like, or select the ones you want. But for sure, this is going to turn workload of faculty and students from 2 weeks down to give me clean data, 20 minutes. So this is an
Mm.
efficiency tool, an effective tool, and an efficiency tool. So yes, you can substitute SPSS or Excel or Stata with Intellectus, no question about it, and move them through so they're not struggling with the tool, but they're getting to what does this mean that, hey, gosh, we have two factors here. That's going to have some
Mhm.
implications for Jeff, that there's two factors rather
Mhm.
than 10 factors or one factor. So these are going to be important things to get to and be able to do that kind of thinking, which is
Mhm.
the heart of what we're trying to hopefully get to students to do. So,
Okay.
yeah. What university?
I teach at Felician University.
Which one?
Felician, it's in New Jersey.
Okay, got it. Yeah,
Yeah.
happy to. And what program, by the way?
A nursing program.
Yeah, we're in about 18% of all DNPs. Is it PhD or DNPs?
DNP.
You're in good company. We're in
Mhm.
lots of them. So yeah, but Ashley and Melissa will for sure follow up with you.
Yeah. And then
Oh, okay.
there's I put in the chat to everyone, there's also a session every Tuesday at 1 o'clock. So if your students want to just come and learn more about the tool, they can do that there. They can register with that link.
Oh, really? You gonna send me the link?
We'll send it to you in an email, and then I also put it in the chat for everyone too.
Oh, that's great. Okay. Yes.
And there's lots of ways of adopting this thing. Either, there's a trial, there's a free trial, wait
Mm-hmm.
a month just to knock out a project. But if you want to adopt it and say, you know what? Let's teach these students this tool. Here's
Mm-hmm.
the courseware to go with it. Adopt it. The students can buy it, the faculty can buy it, but
Mm-hmm.
you'll have a useful tool, particularly for DMPs.
Mm-hmm. Very nice. Yeah, I'm used to SPSS, but
We all
this
are.
is this is all different. I mean,
We're in a new world.
mm-hmm.
So check this out under intellectostatistics.com. Notice we have a whole thing for DMPs.
Oh,
Okay, a whole thing for them with
oh wow.
testimonials. So DMPs were, close to our heart. And
Oh wow.
you can look at the curriculum for healthcare initially, and then there's different options here. So be sure to check that out.
Would you be able to do a demo for the faculty here, so we know?
Yeah.
Oh, okay.
Just get with Melissa or Ashley. We'll get that set up. Happy to do that.
Yeah, that'd be great. So we have
Yeah.
an idea about your database and your software and how to kind of best practices for our students and for us as we are the providers, professors.
Yeah. Thank you
Okay.
for your question. Perfect.
Mm-hmm.
Perfect. Any other faculty considering considering thinking that, hey, this could be beneficial to other faculty and to their students? Any other hand raisers? So Jeff and the two others, okay, so great. So I'm sure that Melissa thanks Cheryl and Georgiana and Stephen. Okay, great. And then Ricardo, okay, wonderful. Great. So we could do lots of things like set up demos, give trials,
Mm-hmm.
and to support you along the way. So thank you all for raising your hands and identifying yourself.
Yeah, great. Really, this is great, and can be a very useful and tool, for the analysis of our analysis that our students do.
Mhm.
For sure. Even if you're not, it's funny. We really have kind of a U-shaped user base. And so what we have are novices, okay, who are new to it, or the programs don't support, kind of strong research, more of kind of applied programs, I'll say. And then you have kind of others that have familiarity and they're really jumping into R. They're programmers, they want to teach the programming and it's free. And so those folks don't typically use it. And then you have the productive people that are doing lots of research. They know how to do R and so forth, but they want that interpreted output. They want to draft in 5 minutes. They don't want to wait for the statistician down the hall. So those kind of the newbies and then those powerhouses are both constituents that find it useful. So what I'm saying is even faculty that are doing research can be very helpful, just as a time saver.
Mhm.
Other questions or thoughts?
No.
No. I look forward to seeing you, and I think Melissa, if it's okay, I'm going to wrap up.
Yep.
Okay.
Thank
Thank you all so much for your attention and sitting in here for 67 minutes. So nice job. And I hope this was really informative. And I hope that everyone gets an opportunity to at least play with it and see if it's a good fit for them and their students. So,
Wonderful.
yeah. Thank
Thank
you
you very
all
much.
so much. Yeah, my
Thank you.
sincere pleasure. All right.
Thank you.
My pleasure. All right. Everyone have a
Bye-bye.
wonderful day. All right. Bye-bye.
Bye.